Hello, welcome, and thank you for joining our webinar today, a modern take on best practices for Unix and Linux security, featuring guest speaker, cybersecurity expert Derek A. Smith. You're also joined by BeyondTrust product manager Rod Simmons, who will run us through a brief overview of BeyondTrust PowerBroker for Unix and Linux solution after Derek's portion, so please stick around for that. My name is Sarah, your webinar host today. A kind reminder to please submit your questions via the chat box in the GoToMeeting console anytime throughout the webinar, and we will cover your questions at the end during our Q&A time. Also, today's session is being recorded, and all those who registered and attended today's session will receive a link to the recording and the slides shown here today within 1 to 2 business days from now. And you should also be able to find the PDF in the handout section of GoToWebinar as I'm speaking. So at this point, I'd like to welcome Derek to the line. Hey, Derek. Welcome aboard.
Thank you.
Always excited to have you at our webinars. Take it away.
And you know I'm always excited to be here. Hello, everybody.
Oh, that's so nice.
Hello, everybody. Happy New Year to you, first of all, and we'll go ahead and get started. So today I want to talk to you about a modern take on best practices for Unix and Linux security. I say modern day because you know Linux and Unix is, well, Unix anyway, has been around for a long, long time, longer than Windows and all that. So today I want to talk about that. And mainly I want to start out by saying you all know that Unix systems face a special type of privileged access management challenge. And I'm going to talk about some of those challenges today. Okay, I'm going to detail some of those challenges. I'm going to explain how they can be overcome when you put the right practices and the right tools in place. So we're going to get into that. And hopefully when we finish, this webinar is going to enable you to be able to enhance your security, achieve compliance, and hopefully I'm sorry, my alarm is going off. Hopefully dramatically increase or improve your operational efficiency within your organization. So that's what we're going to do today, and I'm going to go ahead and get started with the first slides. So let's do that. And again, welcome everybody. I see people still coming into the webinar. So again, here's my goal. I'm going to discuss those challenges, and I'm going to provide you with some easily implemented things that you can do around security. Okay, some easily implemented practices, technologies, some things that you should think about when you're doing this that's going to help you increase your security and all those things. So with that, I'm going to get started, and I'm sorry, you all was just setting, bear with me, I'm setting my time so I won't go over, and there, I've done that. All right, so let's go to the first slide. So a little bit of introduction before I go into 4As, but Unix and Linux, and when I talk in this webinar, I'm going to refer to Unix, but I'm going to be talking about both, okay? They all have foundational technology, or they all are foundational technologies that you're going to find at the vast majority of medium-sized and large organizations. A lot of us are going to have Windows and Active Directory and all those type of things. We might have Mac operating systems, but most medium and large organizations are going to have some mix, some flavor, some type of Unix, okay? And again, I'm going to use Unix for Unix or Linux, whichever one we have here. It's been here way before Windows, as I already told you before, and it's going to be around for the long haul. We're not going to get rid of Unix anytime soon. And why is that? Because it's stable, it has its stability, it's cost effective, it's open. You know, there's so many flavors out there, it has an openness to it. It continues to grow, and there's lots of fans out there who still love Unix and Linux. They hold fast to the virtues that we have around Unix and Linux. But as with any type of technology, we know, and when we talk about real-world applications and implementations of it, using it can actually present some challenges to organizations that choose to embrace Unix, especially around security. A lot of the things that we use out there were not built for security. We've had to retrofit security into those, so that's what we have to do. So the modern realities, because we're talking about modern now, the modern realities demand us to have heightened security of technology beyond the practices that we already have and the practice that we had 20 years ago, of course. So in today's Unix-based environment or based organizations, they have to their accounts have to be much more stringent than in the past. Okay, much more stringent compliance environments are out there. We have to be more sophisticated when it comes to security. Okay, and we have various threats and things like that that we have to be cognizant of, and the demand for interoperability of those systems with the full range of those non-Unix systems like Microsoft Windows and all that are at the front line. So we have to figure out how do we deal with those. Okay, Now, again, I'm going to cover some of the common challenges out there, and I'm going to give you a few practices. Now, I'm not saying this is the end-all, be-all, but if you put these things into place, it's going to dramatically improve your operational efficiency, and that's my promise to you today. So my conversation is going to be based on what we call the 4 A's of Unix Linux security. Okay, and in order for our system to be used, or a Linux system in general to be used, it has to be accessed. Okay, and appropriate access to those system demands have to follow some type of privileged tenets that we have out there, some privileged access management core principles or tenets. And these tenets can be summarized as what you see on the slide here. We have to have good authentication. We have to verify the identity of the person that's requesting access to our Unix system in the first place. Then we have to have good authorization practices. We have to provide the appropriate level of access to that person, to that authenticated person, and make sure they don't have the wrong thing, they don't have the access they shouldn't have. I like to tell stories when I give these presentations. And when I worked at Transportation Security Administration, TSA, we had our director at TSA, he had system admin privileges to our entire system at TSA. And he is not an IT person, you know, he's a director, he's a manager. And one of the people, I found this, I was the information systems security officer, and I found this, and I went to some of the folks and said, he shouldn't have this. And they said, well, Derek, are you going to be the one to tell him? I'm like, sure, that's my job. I'll go talk to him. And believe me, when I told him the implications of him having the type of authorization, the type of access that he had, he couldn't wait to get rid of it. So it's someone's job to make sure people understand their responsibilities, understand their due care and their due diligence. And it's up to people like us, we security folks, to make sure that's happening. Number 3 is administration. So it says the tasks and activities associated with maintaining the life cycle of that user identity, of that privileged access management session. And then, of course, most important but often neglected are audit activities. And these are performed to supply compliance demands that the authentication, authorization, and administration all occur according to some type of rules and best practices. But not only is it for compliance, but it also could be a good tool for us to take a look at the activities that's happening in our system, you know, looking at these logs and these files and doing our auditing to find out where our problems are. And once we know the problems, guess what we can do? We can go back and fix those problems. So every Unix system out there includes a directory that's going to house a collection of those user accounts that we're using, or those user identities that we reference when access requests are made. And consequently, access is going to be granted or is going to be denied based on certain parameters that we set forth and that we put into our directory, and they're going to have certain rights associated with them. Okay, and among those activities, we need to maintain that identity, maintain that access to things like, or for things like provisioning. You know, provisioning is setting up your accounts, through deprovisioning, where we go in and terminate accounts with our PAM system, through account management, managing those passwords, who has access to what type of passwords, making periodic changes, enforcing our security rules that we establish in our organization, making sure it has the right length and complexity, and we changing password when we're supposed to. All these things have to be happening. And guess what? When we deal with a Unix system, they have to happen on every account, every password that's out there. So we have to find a good way of doing that. And I'm going to talk about that a little bit later. So what's the problem with Unix and Linux? Okay, so I know all of you, if you deal with Unix and you deal with Linux, you know this. It's obvious to you that when you have a sizable Unix installation, we have thousands of accounts, you know, first of all, identity management is tough. And of course, PAM, access management, is tough. Okay, it's difficult with the native capabilities that come within your system already, the things that's built into Unix. Okay, with this, it has its own directory, it has its own standalone authentication, authorization, administrative requirements, and all that. It has, when an audit is required, the identity management tasks and all that within Unix has to be performed, as I said earlier, on each and every box. And how are we going to do that? How are we going to maintain that system? Now, I work for the federal government, among other things. I forgot to tell you, but I'm also a university professor, but I work for the federal government. And there was a research done on the federal government looking at the costs associated with providing privileged access management across the Unix environment. and they looked at nearly 250,000 users there that access the system. And they found that $45 million was spent annually on provisioning and deprovisioning alone of Unix accounts and on routine administrative tasks and things like that, like resetting passwords and all that. And they also looked at similar results that were reported on Unix-centric enterprises across the entire range of industries, not just government, from finance to technology and on and on. And they looked at the costs and they wanted to see what these costs were attributed to. Okay. Now, what was the reason for the high cost? They found out that the reason for those high costs was that it's expensive to perform the same routine actions again and again across the systems. We got to go in, we got to go back and change these things over and over again. You know, we're across systems that are not sharing the same basic identity infrastructure or the same password management infrastructure. So managing identities and access for multiple Unix systems is very complex, is very inefficient, because each one of those systems, again, they're unconnected, and each one of them is kind of like an island upon itself, okay? So I'm going to examine some of the specific issues, some of those specific challenges that I'm talking about with each of those 4 A's. And remember, we're building on the tenets of these 4 A's as we go through this. So before I do that, let's look at the type of user accounts, okay? There's a couple of different type of user accounts that we have here. Now, every Unix-like system includes what we call a root account. And I'll talk about that in just a second. And all of them have a single account on the system. Each user should at least have a single account on the system. A root account or a root system allows you to do almost anything in the system. So if you hear, I'm talking about privilege here and defining what privilege is. So first of all, your privilege account are your most powerful users in your organization. That's that root account that I was just talking about. Okay, and those include shared accounts, those include super user accounts that I get to in just a second, and also the regular user accounts that's out there. So every person has a user account where you're supposed to go in and do your day-to-day activity. It's supposed to be separate and different than that super user account that I speak of. Let's take a look at who those privileged users are. So as you see in the slide I have here, those privileged users are identities that have the capability of performing administrative functions on your account. Okay, they can do configuration changes, they can install and execute programs, and if you have an unmanaged privileged account, that's going to put your organization at some extreme risk. And I have some of the risks here. You know, a list of passwords are going to be circulating throughout the organization from those shared passwords, passwords that are never changed. I was just looking at something a couple of days ago where people are not changing, you know, this is not new to you, but they don't change those administrative passwords when they take it out of the box. So I was watching a YouTube video a couple of days ago of hotel rooms, and when they use the safes in the hotel rooms, you can put your password in, but most of them use 999 as their I can't think of their account number that's already on there, comes out of the box. And hotels are not changing because, unlike us, they're not security people. They don't understand that they're supposed to change it. So you can walk into almost every, don't try this at home, folks, but you can walk into almost any hotel room, put in 999, and it's going to open that box, no matter what password you set for it. That's the default password. Next one is employees that have left the organization know the passwords because they're not changed frequently. No entitlements process to verify that users should have the necessary privileges, so they're not auditing, like I said, is very important. You have change in job or roles where additional privileges are granted. Employees copy and share SSH keys. Users inadvertently grant access to the wrong people. Difficulty identifying the number of privileged accounts currently within a network. And of course, insider threat. These are some of the problems, some of the activities, some of the things that happen when you have a privileged user using a privileged account. Now, let's talk about those super users. So that root that I mentioned earlier, or that root super user account, is basically the default account, okay, that comes pre-built with that Unix operating system. And as it says here, they have unlimited access to anything on the system. I hate using the cliche, but they have the keys to the kingdom, as we always hear. Now, those accounts have full read, write, and execute access to perform things like installing programs, modifying programs, deleting programs, and running programs. And you don't want people to have that access to your systems. I told you I like to tell stories, but right now we just had Skype added at work. And with Skype, when you go on and do a Skype live meeting, every time we start it, everybody is the presenter. and you have to turn off everybody being the presenter, and you become the presenter. But the problem is most people don't realize that, just like these type of things. And if somebody pushes a button, it takes down my shared PowerPoint presentation. It changes my speaker. They turn me off sometimes. I hear them talking. So everybody's trying to get used to this thing. We've only had it about 2 weeks. You know, it makes them all that super user for our Skype account. But it caused problems, just like this can cause problems within your organization. So we have something that we want to put into place in order to try to help us alleviate some of these problems that we run into. And we call that our least privilege concept. And you know, a lot of you all are savvy, you're in this industry already, you understand what least privilege is all about. But just in case, I want to talk about least privilege as far as what I'm doing here and how I want to use it here for just a few minutes, okay? So when you talk about least privilege, it says mismanaged privileges pose devastating risks to organizations. And we already know that. If they get in and even if it's not malicious, but someone mistakenly does something, it can still cause us a lot of problems, okay? Including financial loss, including damage to our reputations. We can end up with some regulatory penalties. We can end up losing customers because of the activities that we do or have on our system and our network, okay? It's funny how IT affects everything, including our reputation now. So we want to try to reduce risk around those shared privileges and those shared accounts. Matter of fact, we really even shouldn't have shared accounts, and I'll get to that in just a little while. But reducing that risk around those is our first and foremost need that we have. It's all about accountability. It's making organizations accountable for how they handle those privileged accounts, how they handle those super user accounts. Our job is to try to restrict access to our mission critical servers for the system administrators, for folks who should not be using it, so they won't be able to perform things that they shouldn't be. We also want to make it easy for system administrators who should be performing certain duties to be able to perform their responsibilities without hindrance as well. So what am I saying here? I said we have a balancing act, and it's our job to figure out that balancing act and how best to be secure but not be too restrictive. Let me tell you, there's one way to secure your organization from everything that's out there, and that's basically taking it off the internet. That's basically making it a closed system. But in reality, that's not going to help us. We can't realistically operate with our system closed off to the world. So we have to figure out how best to do what? To mitigate or at least lessen the impact of any type of exploitation or malicious activity or insider threat happening to our organization. And that's our job, and that's what we're trying to do. All right, let's continue on here. So I want to talk about how Unix works, okay? And this is not, of course, exhaustive about how it works, but we're going to talk a little bit about how it works. So every Unix-like system, every Unix file has what's called a file permission. Okay, it has it's marked with some different things that can do. And here I have 3 sets of file permissions that determine how it can be accessed and who can access it. So first you have the permissions for the owner. That's the specific count that's responsible for the file and what's happening in that file and what you're going to do with that file. So you have the file owner. You have the permissions for the group of people who are going to be using that file. And you also have permissions that apply to all the other accounts within your system. And each set has none or more of these permissions that they're able to do. They're able to read, they're able to write, and they are able to execute. Now, reading is okay. Maybe even writing is okay for certain folks. You got to watch out who's executing things like that. A user may only run a program file if they belong to a set that has the execute permission. Okay, so if you have a directory, the execute permission is going to indicate that that user is the relevant person or that has the relevant set to see the files within it and then to make some changes with those files. Okay, they might not actually read or write or execute any file unless that permission that we give them permits it to happen. So we have to figure out and we have to make sure we understand who's executing programs and why they're executing. So your executable files are within your system. We use set UID that has a property in it. They might automatically run with the privileges of that file owner, okay, rather than the account that activates them, and we don't want that to happen, of course, right? We don't want the owner privilege to be given to that person. Our job is to avoid setting the execute permission or setting the set UID on any file or directory unless we specifically want that person to work with it, unless they specifically require it for the job that they're trying to do. So we're going to start with that. We're going to talk about it as we go on. Our job is to make sure, as security people or IT folks, that that user can only run the files that they're responsible for running. Let me go a little bit further and show you another slide about that. Okay? So we're looking at a root, for instance, okay? And we're looking at root ignore. So, root. So root ignores these file permissions. So I'm going to go back in just a second. I'll talk about reading, writing, and executing. When you have the root authority, it's going to overshoot all these things, okay? The root account has full access to every file on your system, regardless of the permissions attached to that file. And I think you know this already. And the majority of the files on our Unix system are going to be publicly readable. It's going to facilitate sharing between, whoever it is that we want to share with, whether it's your organization, your school, whatever it may be. And our job is to try to avoid modifying the positions or the permissions on the system, the files and directories. We don't want people messing in this stuff when they shouldn't be messing in it, okay? And we're going to talk about that as well when we go on also. All right, so let's move back and let's go back to the 4 A's that I was talking about. I want to talk about authenticating into your system, authenticating into your Unix system and how you should do that and what the best practices are for that. So one of the things I talk about is no native single sign-on burdens users with multiple accounts and passwords. So for organizations, for you all out there with multiple Unix systems in your organization, authentication is a box-by-box or a system-by-system process. And each one of your users on your system have to have an account on each system that he or she has access to. And as you all probably realize, if you do this on a daily basis, there's no easy way for you to ensure that those accounts are the same. So errors can happen, and due to those errors that creep into your system over time, inconsistency of the timing of deployment, and the fact that the practices and support staff might change over time. System administrators come and go, they get a better job, they get another job. A single physical user may be represented by dozens or even thousands of different accounts on there, of separate accounts that has no connection with each other. So we can have a lot of problems by not having that single sign-on in the system. So we have to figure out a way that we can deal with that. Okay? Usernames might be different. Passwords might not be the same. They're probably going to be different. They should be different. They expire at different times. So can you imagine the nightmare that we have when we have to go and try to manage authentication and password management of all of these different sites? So in other words, what I'm saying here is that natively, Unix does not provide any sort of single sign-on environment for its users. So users have to access multiple, or if you have to access as a user, multiple Unix systems, you have to remember a bunch of different passwords. And what do we do when we want to remember a bunch of different passwords? We write them down, we put them in a book, we put them under our keyboard, we do all these other things that's against our security policies. Okay? You have to spend a large amount of time simply logging in and out of all these different systems because we don't have single sign-on. So we want to find ways that we can consolidate our logons and our identities in Unix, and we'll talk about how to do that when I get to PAM. And unfortunately, Unix doesn't have a modern way to do that, a way to do that within Unix itself. Second point I have is administrators have to provision each account separately. So same thing, Unix accounts present issues for administrators as well as the end users. Natively is not built to provision all the Unix accounts for a user at one time with some type of single sign-on or single provisioning process. The accounts have to be set up individually, and that's not much of a problem if I only have one account or two accounts, or even if I have 10 accounts or 10 boxes. But what about when I get into those hundreds or those thousands that I talked about before, when our enterprise starts to grow and it has that many accounts? I, as a system administrator, don't want to go into each one of these boxes and try to provision them. The third thing I have here, I have Active Directory Bridge, or you can say PAM bridges, or whatever you might have. They extend authentication and administration to Unix. So for a while now, since the early part of the 21st century, you could say the technology we have out here existed where we can have both native Unix working along with some other kind of thing like Active Directory or like PAM, It's going to extend our authentication security and manageability and single sign-on capabilities that we have. And I'll get to that more when I talk about PAM. Okay? Our job is to be sure that whatever PAM solution that we use, that we choose, it doesn't complement those 4 A's that I'm discussing already. It doesn't make our job harder. It should make our job simpler as we work through this. Okay? All right. Next is are some of our authorization procedures. How do we authorize people to use Unix in our Unix boxes? So similar to authentication that I just spoke briefly about, every one of our Unix systems requires its own authorization as well. So it requires authentication for every box and authorization for every box. So the challenges of that box-by-box authorization can be overcome again by having some type of PAM solution or PAM-based solution that enables PAM-based authorization, or even if it's identity management, because identity management works hand in hand with this privileged access management, as a matter of fact. So we're going to have something where we can group membership, group people into categories of membership, where we can get past some of these administrative and security and compliance challenges that we have that's natively built into Unix. Unix alone is a great program for being productive and getting things done, but for us, security-wise, it's not such a great program for security. Okay, so we need to choose, and in order to choose a PAM solution that it's going to enable PAM-based authorization without introducing additional complexities and all that, we have to carefully choose what we're going to use for that, and I'm going to get to that as well as we go through. The next thing is access management administration for our Unix boxing. So now, I talked about provisioning a little while ago, okay? And I talked about how time-consuming provisioning is for administrators. So when I'm talking about authentication and I'm talking about authorization, neither authentication nor authorization can adequately occur if our privileged access administration or management is not under control. So I talk about challenges here. So again, the challenge with Unix is the fact that identity management and privileged access management, again, has to happen on every box. And therefore, when we're provisioning user accounts for a new employee, let's say, who come in, or somebody change job within the organization, it's going to involve me or you going in and manually setting up accounts on dozens, hundreds, or even thousands of different Unix servers, okay? And for me, probably for you as well, it's almost impossible for me to maintain any type of consistency when I'm doing that, of usernames and user IDs and all that. So the negative impact we're going to have, well, I should say this, there's going to be a negative impact on our I can't say the word, but productivity, okay? And all the provisioning work on that Unix system is going to have to be performed by the administrator, okay? And whose primary job might not be user support, might not be configuring all these boxes. So it's going to cause a problem for us. Second point I have on here is manual deprovisioning processes has significant risk as well. So I already said that provisioning is troublesome, but then we have to go in and we have to deprovision all those boxes too. And while provisioning is troublesome, deprovisioning can be downright dangerous. It can cause problems for us. So we have a delay in terminating access to a Unix system. That can be a compliance issue for us, a violation of compliance at best, or at worst, it could be an open door to some type of malicious activity happening in our environment. All right, we think about breaches like I don't know, Target and Fannie Mae. But let's talk about Fannie Mae. Fannie Mae was a direct result in delays in terminating access to the Unix systems at Fannie Mae. Okay, so with the high number of servers that's involved, or may be involved in your enterprise, your environment, the manual nature of Unix identity administration and privileged access administration, and the lack of some type of centralized oversight by using a PAM system, or oversight that's available in the native Unix, it's going to be a miracle that we didn't have more things like Fannie Mae happening, more access problems and more exploits as we saw in the Fannie Mae some time ago. Next is password management is a drain on users and administrators. Okay, finally, there's that issue of passwords, and I've been talking about passwords and privileged access management systems. Every box that you have requires an account, which means that every box requires a password. And again, the administrative tasks associated with managing those passwords, enforcing the complexity rules around them, requiring periodic changes and resetting forgotten passwords is an incredible drain on operational efficiency within our organizations. Now, this is directly where privileged access management comes in and how it can aid you and things like that. But I'm holding off on privileged access management until I get to that section in just a few minutes. The next thing is unifying identities across the enterprise with authentication services yield significant savings. Earlier, I talked about an example where we in the federal government spend about $45 million annually in order to go into provision, or I'll say provisioning related tasks. And, you know, that's a lot of money, okay, but it's not uncommon. Same thing happened in every industry, as I mentioned before. So one of the things that we're able to do with things like privileged access management is to kind of centralize all the Unix identities and all the Unix passwords and things like that into one easily manageable place where we can go in and look into those. And I'll talk about that as we go in just a second as well. Now, I told you one of the most important things is auditing. Okay, all of us, I don't know about your industry and what industry you're in if you're listening to this, but I'm in the government, okay? And in the government, we have to adhere to various compliance rules, various regulations, various policies and things like that. And compliance and security demands that we have increasing levels of visibility into the access rights of those individuals and the activities that they're performing on our boxes with those rights. Okay, and the common theme of Unix is that again, remember I told you about it being an island upon itself, was a disjointed island, and that applies to the auditing as well. Nobody on this call, no one's listening right now, probably enjoys going in and doing audits. I mean, on a daily basis, we barely have time to go in and do our day-to-day activities. I definitely don't have time to go back and look at audit logs and see what happened on the system. But as you all probably know, because you're experts in this field, auditing is probably one of the most important diagnostic tools that we have, okay? And if you have a privileged access management solution or system, it can make auditing much simpler for you, okay? You can simply go in and pull your Unix identity, authentication, authorization, and administration, my 4 A's, into your PAM system, and that gives you an audit that's going to reveal a lot about what's needed in your system, what's happening in your system, okay? And we'll talk about that as we get to PAM as well. PAM is kind of like a bridging solution that's going to help bridge the problems or the gaps between the native Unix commands and everything that comes with that, with what we're going to supply in that PAM, what we're going to give you through that PAM system. All right. Now I talked about root. And this is a play on the movie, but I am root, okay? What is root account? We talked about that before, and again, the power of the root account and the challenge of managing a root account. We already said that it's a unique challenge for us, and it gives you a lot of power when you have that root account, that root privileged access. And the question when it comes to privileged access management here is, how do we manage privileged or super user accounts? And Unix systems have a single all-powerful administrative account called the root. We know that, okay? It's required for any type of administrative activity that we do. It's required from doing anything from a simple password change or reset to installing new software on our system. And by the way, it can be new malware on our system if it's a bad guy or if it's a mistake. So the account's all-powerful password is often shared across multiple administrators. You know, folks go in and say, what's the password to go on? And we have 3 shifts, and all 3 shifts, for instance, would share that same password. And we know share passwords is a no-no. It's a problem. There's no individual accountability, though, that's going to be tied to anybody who's using that root account. And that's where the problem comes in. There's no native ability to watch what people do with the root account. And there's no way for me to delegate only the appropriate root capabilities for the job to each individual person. So how can I manage that? Well, privileged access management is a way to do that, because now I can go in and set who's going to do what with certain root accounts or with certain accounts. Now, it's a fact that at most organizations already said administrators share those privileged accounts. So how are we going to control those accounts? If we have more than 100 privileged accounts, including multiple root accounts in our organization, and more than half of those accounts are being used by more and more people, how are we going to keep a watch on them? Well, how are we going to know exactly what they're getting into? Now, I'll say this. Unix does give us something to try to help us out when it comes to these root accounts and not giving people more access than they need. And one of those, if you're familiar with this, if you're familiar with Unix, is called sudo. Okay? Sudo helps with the challenge of privileged accounts. But the problem with sudo is that it can't do it all. Sudo has its limitations that we have to be cognizant of. Okay? Now, as you all know, Unix is open source, and the open source community came up with this sudo in order to address the challenges of that root, of root. And by the way, if you're not familiar with sudo, sudo stands for super user do, for those of you who are not Unix user. And what it does is it provides the ability to delegate portions of the root to specific administrators based on their role. So I said before, you want to know who's doing what on an account, you use the sudo command in order to give them certain roles or certain abilities. So this kind of mitigates the dangers of root all or nothing legacy, where if you give them a root account, they have access to everything. Say give them access to sudo, and we can kind of control that just a little bit. Okay, but the problem with it is that sudo has some specific constraints that come with it with the native setup of Unix. Sudo has to be installed on each and every Unix server again. So what if I have all these different Unix boxes out there? I got to put sudo on every single one of them. The policy file that I put together that controls the delegation of their root permission is going to exist independently on each one of those boxes. So again, administrative nightmare where I have to make sure each one of those boxes are set up correctly and doing what they're supposed to do. Sudo does not provide the ability to generate reports on the rights. A PAM system would tell me exactly what a person has done and what they're working with and how they're working. Sudo does not allow that. And again, I told you auditing is very important. Sudo does not provide the ability to audit activity that's performed on the box as well. So we have to look at those challenges and how to deal with those challenges as well. Now, I like to give you actionable items. So let me start by giving you 7 tips that you can put into place and utilize when you want to secure your Unix or your Linux system. And number 1 is pick a good supported operating system. Whatever flavor of Unix that you have out there, you want to make sure that you're picking something that's supported, something that has patches out there, something that's going to give you that has a good track record for supplying security fixes, and doing it in a timely fashion and things like that. Step number 2 is stay current with the patches. A lot of the problems that we run into, matter of fact, nearly every system compromise out there is usually the result of an unpatched system. So it's critical that you go out and not only get all the current patches when you install your system, but that you maintain the current patch level that's in there as well. When I worked at TSA, we used to stay 2 iterations back on our patches. We made a risk-based decision that we would rather have a system we would rather have the system exposed 2 patches back than to patch it and see the patch bring down our system. We just couldn't bring down the system at TSA. But you need to stay current with your patches. Okay. Number 3 is use a firewall, and that goes without saying. Nothing protects a service from compromise like a well-configured firewall. So you want to make sure you have firewalls in place that's going to protect your system. It's going to be configured correctly and doing the job that it's supposed to do. Step 4, use the file integrity monitoring and change auditing. So file integrity monitoring and change auditing is using software that's going to detect changes to the contents or attributes of your file system. So you make sure that you're watching what's going on in your system and that you have a change management process to know what people are doing in there. Keep your clocks in sync. Sounds easy, but if you're using something like Kerberos or something like that for authentication or a PAM system, it's essential that you keep your system clock synchronized to your central servers. Okay, and we'll get into that in just a few minutes as well. Step number 6 is copy your logs to your central log server. I told you that logs are very important. Every time something interesting happens on your servers, the system is going to record that via your syslog, okay? To log, and when a system gets compromised, the first thing that an intruder tries to do is to go in and erase those logs so you don't see all the interesting things that led up to that compromise. So you can thwart this by storing your logs on more than one system, by backing those logs up. Syslog provides a mechanism for me to forward that log to another host so I can put it on the backup system and I can use that later on. And number 7, what I want to get to most of all is use a privileged access management system. Right? So do you want to make sure that the users logging into your system are the users that you think they are? And do you want to set up know what they're doing in accounts, what type of activities are happening in accounts? Would you like to be able to quickly set up accounts for new users without having to go out and set it up for a bunch of different boxes? Then again, PAM for you is the answer. All right, so PAM or no PAM, that's the question. Now, what do we want to do? I just threw this cartoon up. This is what it's like with no privileged access management. Can I access the firewall and change the settings? Sure, here's the password, just go in and do it. Or with the privilege management system, can I access the firewall and change the settings? Yes, prove to me who you are first, authenticate into my system, let me check to make sure you have the right password privileges for doing that activity, and then I'll let you in. And not only am I going to let you in, I'm going to track that activity and know exactly what you're doing and if you're doing the right type of things. All right? So let's get into this PAM concepts. When it comes to PAM revolves around a few simple concepts, 3 main concepts. First of all, who can get access to my server in the first place, and what are they doing on that server? How can they get access to that server? And number 3, what can they do once they get into my server? What access do they have? So there's some concepts I want to look at. How to put those 3 concepts I spoke about to work within your enterprise. And number 1 is PAM can be used to manage your accounts. So if you want to talk about access control and privilege management and things, it has to start with the accounts that you set up to allow use in your system in the first place. So creating accounts in general is pretty easy. I can go in and create an account, but disabling or removing those accounts that are no longer required, that's a big challenge, and that's been a challenge for enterprises for years, and that's going to continue to be a challenge into the future. So that's going to introduce risk into your organization, and that risk that's going to be introduced by leaving accounts active that should not be active has been played out numerous times. If you look in the paper and look in the news in various ways and various exploits, it's been because of these type of things. Historic examples are logic bombs that set to do damage by employees who weren't notified that their account was terminated and things like that. People allowed to continue working and all that. People who were fired and they leave their account open. All these things have to be managed some kind of way. And guess what? PAM helps you manage it in a central location. It helps you manage it much easier. Okay. Number 2 is I talked about the importance of least privilege earlier, and PAM helps you implement least privilege. Okay. So what an account is allowed to do once that person is logged into it is going to be more important than controlling who actually logs into it. Yes, they can get to the account, I manage who can come in, but imagine that everybody in the enterprise can log into your system, and that they can only do, in best case scenario for us, they can only do what's appropriate for their job when they're in that system. A lot of people would not be allowed to do anything at all because we don't want to mess around the system. But the risk of allowing access is far less important than controlling what that person does once he's in it. So I want you to consider a few things when you're in your system. Think about this. Here's a few questions for you. Does every system administrator need to be logged in as a root in your environment? Go back and check and see how they logging in as root, and then you ask yourself, do they need to have root privileges? Ask yourself, do they need to be able to run every command that root has privilege to run? Because you have root privilege, but do they have to do everything? If you have a database administrator, do they need root access, or should they be prevented from running system commands that are not part of their job? And then look at your accounts. What about your accounts used for application-to-application communications? Do they have to have root access? So again, look at your least privilege. Make sure that you're only giving people access and abilities that they need to do their job. Next thing you have to do is they have to help you to manage passwords. Okay? So although we have strong authentication, and I recommend that for people to log in with, there's times and places where passwords are still going to be used. It's still going to be needed. And where those passwords exist, there needs to be some type of managed application of it, some type of way to manage those. And most people have some experience with this, hopefully on the phone call, whether you're technical or not, you know you need to keep your passwords safe, right? But managing those passwords also include things like requiring that password to be changed periodically, not allowing the reuse of those old passwords, requiring that they be some level of complexity in those passwords. Those are all the types of basic password management that we want to have in place. And your PAM system is going to help you manage all those passwords. User applications, functional passwords, your service accounts, all those will be manageable through your PAM system. Next, it helps you eliminate the use of shared account. I told you shared accounts are very bad. Okay, so this is especially important in respect to people that access your system. 2 administrators on the system should not share an account. I already mentioned that. And this, you know, when we talk about traceability and accountability for actions they perform, if they're sharing an account, I can always deny that I did something or that it happened in the first place. Well, it happened, but we don't know who did it, who you're going to hold responsible for it. Okay? And not just administrators of the operating system, but anybody who has access to the system to work on an application or data, your DBA folks and all that, you'll be able to use a PAM system in order to manage how those things are being used. Okay? These accounts are not going to go away. Every Unix system, every Linux system has to have a root account. And a lot of the applications that we have on an account and the different processes we have to have application privileges on that system. How am I going to implement something in order to make sure that it's being done the right way? Control access. Not every account is equal. Not every account available to the system needs to be able to access everything on the network. So if you want to properly implement your privilege control, you want to make sure that you have some type of central way to control access to your account. I'll talk about logging, log changes, log access, log privileges, log failures, log everything. Everything that happens in your system, you want to make sure that you're logging it. Okay? And if you're security folks that's on this call, most security people get this. Most security people understand it. But it also takes, guess what? Time and resources to store and evaluate all those messages that we have. It could be hundreds a day. Matter of fact, when I worked at Army Research Lab, it was thousands a day. And every hour of information that we took in, we had 10 minutes to look it over. Okay? You need to be able to have a way to report on who has access to what and when, because a lot of times this is going to be required by regulation. You know, if you're in the payment card industry on this call, PCI standards require it, SOX standards require it, government standards requirement for us in the government. So you have to make sure that you log in everything. Next is managing and record your privileged activity. Okay, so knowing who has access to what host, when, from where, how are all good and fine, but knowing that that account then elevated or granted privilege to execute additional commands is good to know too. So what if somebody get into your system at the lowest level and they start to escalate their privileges? Don't you want to know that? Okay, don't you want to understand what happened? So if something bad happens, it's great to be able to go back and analyze that data and figure out who did what and how it happened. You know, next you go back and figure out how it happened. So managing this is going to be another activity that PAM is going to allow you to do. Okay. Next is alerting and notifying. So when I find something, I need, not every violation, right? Not every minor violation needs to wake up the security person at 2 a.m. or call the CEO on the phone or whatever. But you should have something that's going to alert you when things are for important activities, okay? For things that you in your policy say needs to be escalated for whatever reason. We need to have a way to do that. And most importantly, it's going to allow you to centralize and unify the different activities that you have within your native Linux or Unix environment. You know, accounts can be managed at the local system with certain things. Privileges can be managed using sudo. You know, everything that can be done is there. But again, I told you that's all an enormous challenge. So we now can couple these things, couple access control and privilege management into a more advantageous one unit that's going to allow us to do these things that we need to do, have better control and better access while we're doing it. Okay. All right, so those are the concepts of how you want to put them in place. Now, when I'm looking at a PAM solution, you know, and things like that, I'm looking at things like the authentication services. I'm looking at the privilege manager for Unix. You know, how we're going to replace sudo because sudo is not sufficient. You know, I'm looking at all these things about centralizing my activities that, like I spoke about just a little while ago. Okay? So what I want to do now is I want to come on and these concepts, these 4 A's that I talk about, I want my partner with Beyond Trust come on and tell us how they look at these and how they deal with these type of challenges and situations that I brought forward to you today. So I'm turning it over. Rod, it's all yours. And Rod, we're not hearing you yet.
Thank you, Derek. I was wondering if you guys could hear me. All right, yeah, so one, I'm waiting to go check into a hotel because I want to try out your secret code on the hotel safe when I get to my room.
It works.
And another really cool thing, just to add on to what you said earlier about time synchronization, recently I was actually at a customer and things just didn't line up. And what they did is they the times were all right, but they had a system in time zone, let's say, East Coast, but the time was reading as if it were West Coast. So everything seemed like it was off by 3 hours. And you're banging your head against the wall, and it's, yeah, they got the time set right, but unfortunately it was set for the wrong time zone. So that's probably another thing really to look into what you were saying, which I thought was really awesome. So jumping in a little bit and talking about what we have to offer with PowerBroker Unix Linux. So PowerBroker Unix Linux focuses on what Derek was talking about, which is that privileged access management at the command line on your Unix and Linux boxes. So we're squarely focused in that server privilege management. We look at what you're doing in the DevOps space or what you're just doing from a traditional management perspective on a day-to-day operating on a Linux box. All of the data from PowerBroker Unix Linux can feed down into Beyond Insight, or you can send the data over to another platform such as Splunk, but you get all the reporting, which Derek kind of highlighted as one of the things that is kind of missing in a platform like Sudo. You get asset management, asset discovery, you get access to vulnerability data so you can make policy decisions based upon vulnerability information. So all of that stuff is kind of inherently available for you when you're leveraging PowerBroker Unix Linux. So what is the product, really, is the question. PowerBroker Unix Linux focuses on a couple key things, which is, one, eliminating the need for sharing accounts. If you're leveraging like a password vault, such as password safe, it may make sense that you vault accounts and then let people check them out and access those credentials. But when you're doing privilege elevation at the command line, you use policy to dictate, I'll let you run these particular commands in the context of this user, whether it be like my Oracle administrative account or whether it be root, for example, we were talking about here. It tracks everything you do. It logs it both just to a regular text log, or if you're recording a session, we do I/O logging, so input-output logging of the user's activities. But everything we're doing around the system is about command elevation and then control. We also provide system-level control. So what we're doing there is we're not just looking at you saying that Rod can run this particular command as this user, but we're looking at the intent of what Rod wants to do. So rather than saying I'll elevate and let Rod run this particular script, we can actually then decide which commands inside the script he can run. So the policy engine or the sophistication of it is strong enough where we can decide to say, I'll let you run this script as root, but if it attempts to do certain things that you're not authorized to do, we'll block those particular commands, would be another example. And then more importantly, it helps across your entire environment. So whether it's Unix, Linux, Mac, this product can sit there. And then we support well over 175 different flavors of those particular platforms. Now, as we sort of jump in, the key is tamper-proof logs. You want to get the logs off the box, is what I always say. The first thing you want to do is, with our perspective, is get the logs off the box. So with Sudo, everything is kind of localized to the box you are on, which is what Derek was talking about. So the logs are on the box that you're giving the user privilege authorization at. So they tend not to be very tamper-proof. It's local authorization versus network-based authorization. So all the policy authorization is remote with PowerBroker Unix Linux in contrast. Sudo doesn't have any official support, but we do have a complementary product that helps out called PowerBroker Sudo. So if you're looking and saying, Sudo might be doing enough for us, and even though these are limitations and we recognize those, if PowerBroker Sudo could centralize the policy file for us so we only manage it in one location, that might help us out tremendously. And then the last thing to kind of think about with Sudo is that when you're trying to manage things across multiple hosts, unfortunately, you're going to have some level of inconsistency, and that's why centralized policy management is important. So I've kind of touched on a little bit of this, and I want to be cognizant to your time because we're coming close to the top of the hour. But you just have to think about, with PowerBroker Unix Linux, again, you get all the key elements you want, which is dynamic access policy. You know, you can allow a user to run commands on remote systems without authorizing them to log onto those systems. So if they need to do checks on systems that are holding like PCI data or SOX data or HIPAA data, but you don't want them to have the authorization to log on, they can run checks from box A, have it check box B, and then spit the results back down to the user, and the user never needs to authenticate on the box. So some very slick things that you get there. Now again, PowerBroker Unix Linux is built ground up for centralized policy management, centralized log management, centralized session recordings. I just talked about the remote host control where you execute commands on the remote box. Very flexible policy language, so you can do things such as time of day that certain people can run things within inside the policy, or forcing for re-authentication, whatever you want to do from there. And then again, the most important thing is being high availability. So you want to make sure that in large enterprises that we can scale out, and we support customers that have, you know, anything as few as a couple dozen servers to 240, 250, 500,000 servers we've been dealing with large enterprises. So the advanced audit control is what I was talking about. It's where we're peering inside of what the user's trying to do. So we're essentially managing it based upon the user's intent versus based upon something as simple as what the user types in. So yes, you can elevate this script, but if that script attempts to reboot the box or something like that, we'll block those things. Additionally, we provide a file integrity monitoring component that can look at files. So if you have certain sensitive files, such as the various settings files that you might have located throughout your box, you can actually put integrity monitoring on those, or certain binaries you want to monitor because users are using those all the time. You don't want them swapped out for malicious files. We can actually monitor those and then report back up when those files particularly change. All of the data that's happening in the product is all indexed, which just means it makes it really quick. So whether you're using Splunk, which we have a component that's coming out here in next month for our Splunk plugin, you're sending it up to our Beyond Insight console, getting all your reporting your data. It's really just your ability to customize and get reports out of the data that's being generated from the system, and that's the most important thing that you really need. So I'm going to skip to how it works just because I want to, in the interest of time, I want to make sure I get 2 seconds to get you guys into a demo. And let's see if I can get over to my demo box here. Perfect. So I'll give you a really quick example, and I'm only going to do one of my many demos I was going to do. So so we just prefix our commands with pbrun, and I'll just give myself a root shell. So once I've jumped into a root shell, I'm kind of in here, and then I'll switch over to my scripts folder. And this is going to show you how our advanced control audit works. So I'll just do a, sorry. What is that file called? Sorry, let me list it. Demo script, sorry. So what you'll notice in my script file is that I'm going to attempt to reboot the box. You'll see a lot of things going on there, but the most important thing is that this should be an epic fail. We should never get the script complete because I'm going to attempt to reboot it. So when just so we're aware, I'm logged in as root. When I did a pbrun bash, it gave me a privileged shell. You'll also notice that I'm going to try to run the command who am I, and it's just the probably most benign command you have on the system, but you'll notice that I'm not allowed to do that even though I'm in as root. We're blocking that. So what I'll do really quick here is I'll just do a sorry. Can't type today. So I'll execute my script. You'll see it starting, and it's doing whatever it is in there, but you'll notice it completed. And fortunately, you'll notice the box hasn't rebooted. So I can type in my commands. I can exit out of here. The box never rebooted. So what happened is the Advanced Control Audit was told Rod is not allowed to run the reboot command. So it knows that it originally was me that got the root shell, and when I initiated that reboot command on the box, it said, nope, reboot won't happen, and it blocked that. And those are some of the cool things. Now, an administrator who wants to watch that same session will take this file here, and I believe, let's get that. And sorry. I cannot type today. And let's just play that file back really quick. You can see all the commands that I was typing while I was in that session. So very quick and easy for you to see that I got in, I did the ID, who am I, the catted out the file, and all that stuff. But more importantly, you'll be able to see what commands were run, what commands weren't run, all that type of stuff within inside there. So very easy for you to kind of see what a user did in a session, and that's one example of a playback. Now I'm going to pop back over, oops, sorry, let's get out of here. I'm going to pop back over, to my PowerPoint presentation. Oh my gosh, having a bad day. There we go. At the PowerPoint, and I'm going to pull over because I think we have a time for Q&A and a poll for you guys.
Thanks,
so Sarah, I'm going to turn it back over to you. Sorry.
Awesome. Yeah, no worries. Thank you. Okay, so let's go ahead and jump into our last poll. Would you like to schedule a one-on-one demo with a Beyond Trust security engineer? Let us know. Select yes. They can walk you through a more thorough one-on-one demo. I know Rod briefly touched on some of the capabilities of PowerBroker for Unix and Linux. If you'd like to see something a little bit more in depth, select yes. Somebody will be in contact with you to schedule that. Let's go ahead and dive into a couple of questions that came in from the audience. Derek, make sure you are unmuted, and let's go ahead and fire through these. So Derek, are most companies using Windows AD for authentication even though it's not native?
I'm sorry, could you repeat that one for me?
No problem. Are most companies using Windows AD for authentication even though it's not native?
Yes. Now, I'll say this. I think that a lot of companies are using a combination. When you have a Unix system, a lot of companies are using Active Directory as part of that process for authenticating into their system. Most of the places I've seen has had AD in that environment. So I think so. You want to add to that, Rod?
Yeah. So what we're seeing is, yeah, a lot of people are actually leveraging Active Directory for an authentication platform. One, it's prevalent through most organizations, and then most importantly, there are well-known solutions that provide AD bridge type technologies, such as our PowerBroker Identity Services solution.
Yes.
Derek, will PAM tolerate applications using shared accounts?
Matter of fact, I'm going to pull that. I'm going to let you start with that, Rod.
Yeah. So yeah, privileged access management, does it tolerate shared accounts? I'd absolutely say yes. Typically, if you really want to do it right, what you want to do is vault those accounts. So you'd leverage something like Password Safe, put the credentials in a vault, and then when users need them, they can check them out. If you want absolute certainty of who's using them, you only allow for one concurrent checkout, which means I can check it out, but no one else can have it now. Once I'm done with it, it scrambles the password, and then the next person gets in line. That way I have total accountability on the usage of that account. So it is a tolerant, it's a different approach from just doing true privilege elevation. You're really looking at going a different route. Now, what Derek and I talked about today was using solutions like sudo, PowerBroker Unix, Linux. And what those solutions are designed to do is leverage policy to allow you to run certain commands in the context of another user without ever knowing the credentials. And that's another approach to it. That doesn't necessarily work very well on Windows, but that gives you a general idea.
And the biggest thing, as Rod said, is about accountability. So I still advocate for not using shared accounts, but if you have to have them, vaulting is the best way to know who has what and what they're doing at the time they're doing it.
The only place we manage accounts and privileges organization-wide is Microsoft Active Directory. How can we use this for Linux and Unix access?
You want to take that one, Rod?
Yeah, I'd say, again, going right back down to the AD bridge. I mean, there's open source solutions that provide you. So Beyond Trust actually even has one. It's called PowerBroker Identity Services Open. You can start with. There's other open source solutions like from MIT that you can leverage for AD bridging, or you can go with our enterprise-based solution, which gives you both the authentication piece of that, but also pushing down group policies. And again, you'd be looking for a solution like PowerBroker Identity Services, which provides a bridge where you leverage your AD accounts to log on to Unix and Linux, and they would get UIDs, GIDs, geckos, home directory shells, all the key things that make a user a Linux user. And all of that stuff is pushed into AD. It doesn't require scheme extension as long as you're, I think it's 2003 R2, which actually has all the POSIX attributes you need.
If you have Unix users doing ID authentication to Windows Active Directory, is there a way to distribute SSH keys for those users to eliminate use of a shared account?
So you're gonna have to repeat that. If you have 80 users doing log on to Unix systems,
yeah,
you want to use SSH
Unix
keys.
Users doing ID authentication to Windows AD, is there a way to distribute SSH keys for those users to eliminate use of a shared account? So Unix users doing authentication to Windows Active Directory.
I think the question, we might be getting the question slightly wrong, so let's skip that. But if they want to re-ask it, we can definitely answer it.
Yeah, Aaron, if you want to, if you're still on the line and you want to clarify, we can try to touch base on that. Let's see. Steve asked, we're currently using Splunk for SIEM for all Linux and Unix. When will PowerBroker plugin be available?
So we're in the final phase of testing. We're planning on having the PowerBroker plugin for Unix and Linux later in the month of February. If you want a demonstration of that, I would say contact Sarah. She can get you in contact with the proper sales rep, and we can get a demonstration of that so you can see what we're doing there.
Yeah, absolutely. Rod, does PowerBroker give you the ability to distribute SSH keys?
So for SSH key management, our PowerBroker suite does provide that. We provide that specifically within the Vault component in PowerBroker to provide SSH key management across the enterprise.
Okay, last question, you guys. Nope, let me see. Let me look for it. Just moved on my screen. What is the main difference between AD and PAM? Why would someone go for PAM and not AD?
Well, AD, sorry, I apologize, Derek, I just keep talking. AD, look at that as it's just an authentication platform and authorization platform, if you will, for Microsoft Windows. PAM is just privileged access management. Two fundamentally different things. You can have privileged access management over Windows. So a good example within the PowerBroker stack, we provide that. We also provide that in a Mac solution for PowerBroker for Mac, PowerBroker for Windows, which does privilege elevation on those platforms. That's or what I showed you on PowerBroker Unix Linux was privilege elevation on Unix and Linux. AD is just one more platform that you're dealing with. So it would be like saying, why would I go with LDAP versus PAM? And it's like you're comparing apples and oranges. If you sell the LDAP and AD, I totally get it. And I'd say go with whichever one you choose. But if you're talking PAM versus this, it's whether or not I implement a privileged access management framework over top of the platforms we're using. And AD would just be one of the many platforms you're doing privilege control over. AD, Unix, Linux, and then all your various applications you have and devices.
All right, guys, we are over the hour, so I want to be cognizant of everybody's time and wrap this up. Thank you to everybody who submitted their questions. You will be receiving a follow-up email with a link to the recording and the slides shown here today within 1 to 2 business days from now, and it will come from our email alias communications@beyondtrust.com, so be on the lookout for that follow-up. Derek, Rod, thank you guys so much for being here today and sharing all of your PAM insights. We really appreciate it, and we will see you guys at the next one. Take care, everybody, and goodbye.
Thank you, everybody.
Thank you.
Send us your questions.